So, good morning, one and all present here. I am Metha Surendranath, Executive Member of Breakthrough Science Society Kerala Chapter. Today, I welcome all to this interesting webinar on the title Science in Ancient India and Evaluation of Claims that's being organized by Breakthrough Science Society Kerala Chapter as a part of observance of National Science Day. So today we are so privileged to have two eminent personalities with us. We have Professor Soumitra Banerjee, the General Secretary of Breakthrough Science Society, to inaugurate this webinar. And also we have the eminent Professor Mayank and Vahia to give a lecture on the title Science in Ancient India and Evaluation of Claims on this particular day. So it's our privilege to have these two eminent personalities with us. Without wasting time, I would like to move on to the formal welcome speech for this particular webinar. So I welcome firstly Professor Soumitra Banerjee, General Secretary of Breakthrough Science Society All India Chapter to this particular webinar. Welcome you, sir. And also, I would like to welcome Professor Mayank and Vahia to this webinar on behalf of Breakthrough Science Society Kerala Chapter. Welcome you, sir. And I would like to welcome all the participants and viewers both in Zoom and in YouTube who are watching this webinar. And I expect all to have, we appreciate active participation of all the participants and viewers in this particular webinar. And there is a short announcement for you all that you can put your questions as well as comments in the chat box, and that will be taken up at the end of the presentation of Professor Mayank and Vahia. So firstly, we will move on to the formal inauguration of this particular webinar. So I invite Professor Soumitra Banerjee, who is the General Secretary of Breakthrough Science Society All India Chapter, and also Professor at ISA Calcutta. So sir, moving on to you. Thank you.
Thank you, Medha. As you know, in 2020, a new education policy has been tabled in the parliament and has been adopted by the ministry. And that new education policy talks about something called Indian knowledge systems, or in some pages it is also called the Sanskrit knowledge systems. And in that, there are various claims that are being made regarding the history of India, the contribution of India in various areas of science and technology. And most importantly, there is an attempt to rewrite history. In this situation, as a science organization, the Breakthrough Science Society feels that we should take a look at the claims from a scientific perspective. And as you know, science is based on evidence. So what can we really conclude based on evidence? This is the question that we are asking. And we are organizing a series of webinars and discussions on this topic. Essentially, we are trying to figure out what exactly can be concluded based on the evidence that we have, and whether or not the claims that are being made can stand on a scientific ground. And with that objective, we had requested Professor Mayank Vahia, who has been, he's a very eminent person in the field of science. He was a faculty member in the TIFR, Tata Institute of Fundamental Research, and he has done extensive work on history of astronomy. So who else would be better than him to talk about this topic? So we requested him to talk about the claims regarding the science in ancient India and how much of that can be accepted based on evidence. So with that short welcome address, I'll now hand over to the organizers. Thank you.
Thank you, Professor Soumitra Banerjee. Now we will move on to the interesting session of this webinar presentation by Professor Mayank and Vahia, Professor at Tata Institute of Fundamental Science Research. So Dr. Mayank and Vahia was a professor in the Department of Astronomy and Astrophysics at Tata Institute of Fundamental Research, Mumbai. He did his PhD in astrophysics from University of Bombay in the year 1984, and his major research areas are high-energy astrophysics, mainly cosmic rays, X-rays, and gamma rays. He has participated in the solar X-ray spectroscopy experiment that was launched on India's GSAT-2 satellite in 2003, and currently involved with the AstroSat, India's multi-wavelength astronomy satellite. He has also associated with several universities abroad for his research like Max Planck Institute of Physics, Astrophysics Germany, University of Durham, UK, and University of California, San Diego. His latest area of research is in the field of archaeoastronomy, a multidisciplinary subject that focuses on learning about the ancients from their astronomy. He is also a member of the Archaeological Society of India. Professor Mayank Vahia is actively involved in popularization of science. He had served as the director of Nehru Planetarium, Mumbai from April 2001 to June 2002. He has keen interest in science and education and in the impact of science on society. He has created many programs and delivered many lectures to students on issues of astronomy as well as science and society. He was also the chairman of Science Popularization and Public Outreach Committee at TIFR. He has published several popular science articles, including the one published in Current Science Journal titled Evaluating the Claims of Ancient Indian Achievements in Science. On behalf of Breakthrough Science Society and all the participants of this webinar, I warmly welcome Professor Mayank Vahia to this program and request him to start the presentation. Over to you, sir.
Thank you very much for that flattering introduction, and Dr. Banerjee and all my friends. It's a great pleasure to see you once again. And I've been given this task of critically evaluating India's claims in science and various fields of science. So in the first part of my talk, I'm going to talk about what are the achievements that we can actually claim rightfully to be ours and their interesting aspects and so on. And in the second half, I will talk about what we did not achieve. And eventually I will discuss this subject of how do you independently evaluate whether Mayank Vahia is right or whether somebody else claiming to be a proponent of science is correct or not. You should be able to judge on your own as to what is right and what is wrong. And we will look at some of the aspects of how that can be judged. So that's going to be the three parts of my talk. And once again, thank you very much for this invitation. And let me start with my talk. So how did science originate? That if you look at any textbooks, it begins with Greece and then goes on to 16th century Newton and others, and claims that that is all that science is, that any book of history of science needs only to have the early Greek scientists and then go straight to the European scientists of 16th century, and nothing else happened in between. Nothing can be farther from truth than that. Every culture, every society has had its own significant contribution to science. And Europeans, being Eurocentric, they have emphasized their part of the story. So there is a certain amount of lack of appreciation of the contribution from other cultures. At the same time, in trying to sort of push your claim, if you overdo, people will just mock you. People will just make fun of you and say that, oh, you claim everything that is true. What is the prediction that you're making from your ancient and science texts that we don't already know? And that is when things start getting muddy, because all predictions are post-facto. We knew this, we knew that, we knew that. But this is what is the scientific prediction based on my ancient text. And please verify it, kind of ideas have never come. Everything is post-facto. And that gives you a horrible name and a horribly bad reputation. So we should know what we were good at. We should know what we were not good at. And we should know how to evaluate new claims that come up. And that's going to be the emphasis of my talk. So scientific inquiry started when the first human being started looking for a stone around him to cut an animal that he or she had hunted. And then eventually that becomes systematic, because once one person has found a good knife or a good stone to cut with, it should be reproducible. You can make more tools of the similar kind and all that. So look at the nature, and see that the nature's results are reproducible. That if I take this stone and hit it in a particular manner, I get a very sharp-edged tool, which I can use for cutting animal skins and eating the innards of an animal. That is where science begins, and it doesn't even begin necessarily with human beings, as we will see. So this curiosity about how nature works and how can I confirm that the nature works in this way through reproducible experiments is a very old idea. All cultures and all civilizations have contributed to it depending on the capability and environment of the civilization. Each group has sort of done discoveries and inventions according to what their own environment and their own requirements were. We won't touch the story in detail over here. If you're interested, there is a paper in Current Science where I've sort of illuminated it in length, where we have talked about 4 phases of development of science: the ad hoc science, the religious science, the formal science, and then eventually where the science is going today. But that is not a topic we will touch today. What we will talk about is the claims and counterclaims and story that relates to ancient Indian sciences. Some important landmarks in the development of science come from the fact that even animals use tools in order to do their to exploit nature to their requirements. So here is an example of a parrot trying to use a stick in order to bring that cashew closer to himself so that he can eat it. Here is a monkey, orangutan, I think, which is trying to put sticks into a beehive on an ant hive in order to catch ants and eat them because he likes animals. So use of tools is not human specific. Even then, if we stick our stories to humans, because we really don't want to get distracted, then Homo sapiens arrive on Earth about 1 million years ago. The brain is slightly smaller, but they are essentially the archaic humans who they are walking on 2 legs and their hands are now free to do various other activities. So they developed flake tools about 500,000 years ago. 5 lakh years ago, humanoids, Homo sapiens start using tools. But the hominoid use of tools is as old as 2 million years old. Even in India, there is a species of hominin that was discovered in near Chennai in Adambakam, which was using good stone tools as far back as 1.8 million years ago. And these are archaic humans. They are not human beings in the sense that, sorry, they are not Homo sapiens sapiens. They do not have the 1500 cc brain. They do not have a capability, the comfort of walking straight, and the brain size, most importantly, is slightly different. These hominins were slightly shorter than humans. They had slightly smaller brains, but even at 1000 cc or 800 cc brains, they could still learn to understand and manipulate nature. And so Homo sapiens sapiens would eventually catch on to this. Anatomically modern human, what we would call Homo sapiens sapiens, brain size of 1500 to 1350 cc, completely walking straight, being able to use jewelry, and somebody whom we would be able to recognize as a modern human and who could fit into a culture, into the civilization of today, is about 200,000 years old. But this is anatomically modern. It takes another 150,000 years for human beings or human brain to realize the body it has, the capabilities of the brain it has, and the formation of the society, the formation of language, the exploitation of proper language, organization of a group into various subgroups of family and all that comes about 50,000 years ago. So it takes human beings about 150,000 years ago just to fully understand the capability of their body and the capability of their mind, and to start organizing themselves in terms of language, in terms of map making in the brain and so on, by about 50,000 years. It takes them 150,000 years to be able to figure this out. So humans spread across Africa about 200,000 years ago. Before they are once they become anatomically modern, they are now capable of great feats of travel, and they realize the population densities are not able to sustain the hunting. So they would go hunting at different places. They would look around at different places. They would go further up and explore by about 200,000 years ago. The earliest bed that we have is dated to about 200,000 years ago, where in South Africa, we have found a collection of twigs and wood weeds, which would have been soft enough for you to lie down on without feeling the hurt of lying down on a stone. And we, considering that is the width of a human being, we believe that is the earliest bed made by human beings using leaves and twigs and so on to sort of soften the burden of lying down on the ground. The earliest jewelry in terms of seashells with holes in them and so on are found about 135,000 years ago. So the first use of human beads, again in Africa, is about 135,000 years ago. The first evidence of controlled fire we have is 125,000 years ago, in the sense that a small fire, we did not light up the whole forest, which remained localized to a couple of half a meter or less, presumably used for cooking and so on, comes about 125,000 years ago. Language, and I'm sorry the color has gone bad, language appeared about 100,000 years ago. So if human beings had the capability of complex sound vocalization, which of course humans knew about 200,000 years ago, but formalizing and grammatizing it comes to about 100,000 years ago. And the way we make out, language is not a tangible entity, but the way you can make out how language must have come is by looking at how you pronounce and how you use sounds and words. So just as you can do genetics of life, you can do genetics of sound. And that tells you, or genetic of languages, and that tells you that the earliest language is about 100,000 years ago. Human beings start migrating out of Africa between 100,000 years and 70,000 years ago, and then they start spreading all over the world. The first evidence of humans wearing clothes based on their terracotta pieces on which there are cloth marks and so on comes about 70,000 years ago. Especially once they reach out of Africa and start reaching cold weathers, they would obviously need clothes to protect themselves from the winters. Traps to catch animal, as far as we know, the oldest ones we know are about 70,000 years ago. Even though there is this very romantic pictures of humans in a group hunting mammoths and all that was very rare. For a long time, humans were hunters of small game, rabbits, goats, and so on, eating them. Larger animals are very rare catches. So by and large, but even then for catching rabbits, etc., we have the earliest animal traps about 70,000 years ago. As far as we know, the humans discovered this interesting property of bamboo, of its stretchability, and convert that into a bow, and eventually a bow and arrow system comes around about 64,000 years ago. Then humans spreads into Africa about the time of 50,000 years ago and start spreading everywhere. So once they become behaviorally modern, they start spreading all over the world. And by about 40,000 years, you find them in Europe already, and they would have come to India also. But by about 40,000 years ago, you find them in Spain, Germany, Africa, and you can see earliest rock art around that time. The earliest known female figurine, this is about 4 or 5 centimeter long statuette of a female with exaggerated genitals, comes about 35,000 years ago. And this could easily be the worship of Mother Earth and fertility highlighted, or it could be anything else. But the earliest statuettes of actually carved human shapes is seen as far back as 35,000 years ago. Pottery is invented in China now around 20,000 years ago, where they make these thatched vessels in which to store water or whatever you want. The first drawing of constellations found in a French cave in Lexus is about 15,000 years ago, and clearly you can see Taurus, Pleiades, and Orion drawn out properly. Major transition comes about 12,000 years ago, when humans start worrying about farming. So farming and animal domestication, and more than simply foraging, comes about 12,000 years ago. Till then, human beings are only foraging. But now they start farming, and farming and domestication of animal means people start living at a static place. They were no longer wanderers. And that would bring a lot of changes in human life. So metallurgy comes up because now human beings learn to control fire, to take fire to reasonably high temperatures so that you can get copper from stone and so on. So metallurgy comes about 10,000 years ago in Central Asia. Writing, the earliest evidence of writing we know is about in West Asia, in Mesopotamia. Harappan writing is about 5,000 years old. As far as we know, the oldest wheel and related technology come from Mesopotamia about 5,000 years ago. But these phases can certainly build up to these qualities. So it is not that on this particular day things started. There was a gradual buildup of knowledge and information and experience over a period of time. Seeing a rolling stone or seeing a rolling tree, and the idea that you could carry things on those things would come up, and then people would sort of brood over it and then eventually come up with wheel. So everything would happen gradually. There is no sudden step function change in knowledge. Everything is gradually building up. Then if you look at more recent human beings, the horses come to human beings about 6,000 years ago in Central Asia. And they eventually come to India about 4,000 years ago or so. Originally, it's an American animal that is extinct in America, but that crosses over to Alaska and comes to Central Asia, where it is for the first time domesticated. And eventually people realize the power of having a horse, and then the horse spreads very quickly over the Euro-Asian landscape. Bronze and copper get discovered by about 5,000 years ago, and Harappan civilization essentially is built up on bronze and copper. Pyramids are about 4,500 years ago. Harappan cities are also about 4,500 years ago. They lasted for about 1,000 years, but their cities are 4,500 years ago. Earlier to that, Mesopotamia has cities and so on about 7,000 years ago. First major religious text in India comes about 4,000 years ago. So we suspect that the first foundational shlokas of Rigveda, etc., were probably written down, were probably composed 4,000 years ago. They don't get written down until turn of the millennium, 300 BC or so. But they are composed probably much earlier. And if you look at somebody like Tilak, he says that it carries memories of things that were 7,000 years old and all that. There is a suspicion that there is an older religious text, which is Avesta, which is a Parsi or Persian book of religion, which must have existed in Persia or present-day Iran, but that is more or less completely destroyed. We don't have any copies of that. But there are some interesting hints in whatever little scratches we have that it was contemporaneous to Veda, or probably even slightly earlier than the Vedas. Mahabharata can be comfortably dated to 3,300 years ago. Iron is discovered in India towards the end of Mahabharata war, and in the world also around 3,300 years ago. You can push this by another 200 years or so. Greek civilization, on the other hand, peaked at 3,000 years ago or 1,000 BC in Greece. Persian transcontinental kingdom, the first genuinely world kingdom, comes up from Persia in 2500 BC. They start from Iran, but they come to Hindu Kush mountains and eastern regions of present-day Pakistan, all the way to Spain and Central Asia, Central America, and then they go into Turkey and Greece and so on. 2,500 years ago. Vikram Samvat, the earliest known calendar in India, which is still continuing, comes at 2072 years ago. So it is older than the Christian calendar. It was founded in the memory of Vikramaditya of Ujjain, and therefore it is called Vikram Samvat. So Vikram Samvat dated to about 58 BC. Shaka calendar, which is also very commonly used, comes in 1993, so it is 78 years old, younger than the Western calendar. And that is again, Shaka is a period and against which it starts. Ghazni invaded India 1,000 years ago, coming from the steppes of Mongolia and so on. European expansion into the world actually began 500 years ago, armed with guns, germs, and steel, as it were. They made these huge, powerful weapons of partly the weapons like guns, etc., partly carrying germs, which many civilizations did not have immunity against. So there are groups of civilizations that have been wiped out by smallpox, for example, because the Europeans had smallpox and immunity to them. These other cultures did not. So a combination of guns, germs, and steel would make European expansion possible, but that is just 500 years ago. Babur comes to India around the same time of 500 years ago, and he makes his Taj Mahal around 400 years ago, and it's a technological marvel by any standards. Telescope is invented around the same time at 400 years ago. Jantar Mantar comes to India and so on. Aircrafts were invented 100 years ago. And I was born, 65 years ago. Essentially, there has been a continuous progression of development of ideas and culture, and there is nothing that would suggest that there was a dramatic change. There have been times when the developments have been quick. So for earlier developments based on inductive logic, that is Indian, you get a huge amount of development, and we'll look at some of that, but then that stagnates. And then the axiomatic approach of Europeans, which originally did not lead anywhere because they didn't have the knowledge base that was needed. But in 1600, with the knowledge base taken from China, India, Arabia, etc., and using these axiomatic methods that were there in the Greeks, there was a stage when there was a major development of science. But they are all built up on the previous knowledge. There is nothing dramatic that nobody knew and everybody came to know the next day. Science does not begin with Galileo throwing a stone and a feather down the Leaning Tower of Pisa. So what are the earlier sciences? A lot of earlier scientific progress comes from Asia. Chinese make some good instrumentation, etc. But China is so far and so isolated that their work remains isolated to China. On the other end, the southern Eurasia, India, Arabia, Persia, Egypt, and Greece, Mediterranean Europe essentially form one belt of knowledge. So Mesopotamian culture in Tigris and Euphrates, which are now in Iraq, flourished around 3100 BC. It was the peak of cultural development. The urbanization, etc., goes even further. They were urbanized, had farming, and they worked in astronomy, and their arithmetic was excellent. So not only did they have decimal system, they also had hexadecimal system for calculating more complex things. There are actually multiplication table tablets you can find and so on. Indian urbanization is good 300 years later than that. The earliest evidence of Indian urbanization comes to about 2700 BC, that is 4,500 years ago. It is contemporaneous to Egypt and Central Asia and peaked around the same time. And they also die around the same time. For almost 2000 years, for 600 BC to 1600 AD, India was one of the most significant centers of learning in the world. We eventually go into a decline because the kingdoms get distributed so small that none of them is viable, incapable of supporting scientific research and so on. And eventually India goes into this quasi-dark ages. Nothing compared to European dark ages, but quasi-dark ages come to India. But from 600 BC till well into the AD, India is the dominant scientific power in the world. India's decline, as India declined in knowledge, the Arabs came forward and collected a lot of this material and kept it for us. So if you look at Al-Biruni's India, for example, he gives beautiful description of Indian science, but he also notes that these Indians have become so arrogant and so xenophobic that it is going to lead to their downfall. And sure enough, in another 100 years, India gets into a downfall because they become xenophobic. They do not take ideas from others. They become rigid. They do not discuss ideas. The intellectual creativity is no longer the thing. And we become very arrogant, as a result of which this continuous flow of knowledge that is necessary comes to an end and India goes into decline. So science and technology, let us look at what Indians were good at. So you can divide it into three different periods. The earliest period is 1000 BC. In 1000 BC, you have Harappan civilization, which by every stretch of imagination is one of the finest. Orthogonally laid out cities, standardization over 1.5 million square kilometers, use of 1:2:4 bricks, the cross-logging of bricks, which would make them more stable, beautiful artwork in their terracotta seals and so on. And you get a sense of a culture that is doing well. Jewelry is there, highly standardized blades are there, highly standardized writing is there. We still don't know what they wrote, but we know that the writing is extremely well standardized. And it's not easy to have a writing standardized over 1.5 million square kilometers. Even in India today, over a period of over a distance of few hundred kilometers, the vocabulary definitely changes, and even the script changes over 1,000 kilometers. And yet Harappan civilization had a standardized script that went to 1.5 million square kilometers. Then Sulba Sutra come in 1000 BC, where you have the first mention of Pythagorean triplets. We don't prove the Pythagoras principle, but we know there are triplets where a square plus b square will give c square. A, b, and c are all three are integers. That's a good 500 years before Pythagoras. The reason why Pythagoras gets the credit is because he actually proves that it is generally true for A, B, and C being rational numbers, you will get, for any A square plus B square, you will get a number C square, which is also a rational number. And that it comes out to be a right angle triangle. That proof is given by him. Indians knew of Pythagorean triplets because they needed to make Havan Kunds, etc., where the bricks had to be made, and those bricks had to be made in standard sizes. And so scaling up required knowing Pythagorean triplets. The number system, the counting system based on location-based value system, it is used earlier elsewhere, but the ideas of using powers of 10. So there are blessings that are given in Rigved which says that may you have 10 raised to 7 cows and stuff like that. That idea comes from India first. The first major constitution is also written in Mahabharata, where the duties of the kings and the responsibilities of the king and the way king should behave are all listed out. And for all the complaint that one may have against Dushasan and Duryodhan, the fact remains that there was no revolt amongst the civilians of Kurukshetra, because as kings they had obeyed their duties, and those duties are definitely formalized and finalized. They had their fights with their brother for who should be the king and related issues, but that is a different part of the story. The exact duties and responsibilities of the king, and that is when India goes from, by the way, becoming from a clan society to a formal civilization around the time of Mahabharata's beginning to end. Then this is, for example, Mohenjo-daro. You can see this much is 100 meters. So you can see there are 50-60 meter long streets. You can see how there are orthogonal roadways. The roads are not random, but they are also this great bath and so on. The whole thing is on an artificial mound because of the fact that it is in Indus plains, and Indus can easily sort of drift along. The whole thing is made on an artificial mound. Technology of that quality existed at that time. No pyramids, but certainly extensive engineering and planning skills existed at that time. Well, then India comes into its golden age from about 1000, more like 600 BC till about 400 AD. And there are various developments that come up. It's a late Vedic or Gnostic period of the time when the idea of Vedas and gods as Vedas are challenged, and people start becoming Gnostic. So Panini writes his grammar at that time, 6th to 4th century BC, which gives you exhaustive formulation for linguistic grammar. So you have a problem that the traditions of writing are not the traditions, are oral. And if oral traditions are there, you have to worry about propagation of that sound in a perfect manner. So there are various levels of compression of text. And Panini's grammar defines those compression methods very beautifully in terms of 6 rules of where the sound can disappear or where the sound can be replaced and so on. That comes around 6th to 4th century BC. He himself says that he's simply collecting the rules that are available. He does not create them. So there is a literature of, there is a culture of formalizing everything. And Panini formalizes grammars 6th to 4th century BC. Buddhism and Jainism come at this time for the first time, challenging the orthodoxy of Vedic or even the karma-based religion of Hinduism, and they come up with their own thoughts, refusing the authority of Vedas and so on. The first university at Takshashila comes in 8th century BC and lasts till 6th century AD. That is 800 years. Okay, Mumbai University is proud at being 125 years old. These are 800. They lasted for 800 years. Nalanda is 5th century BC to 13th century AD. 15th century BC to 13th century AD. Another again 1800 years for which it lasted. So those kind of long sustained places where knowledge was assimilated, where teachers were given proper respect, and where teachers were involved in doing research and development of knowledge is quite old. Then you get the 6 great books of Indian sciences at that time. So Nyaya and Vaishashika become the first set of books, which are the first genuine secular books of science. So if you look at Vaishashika, for example, it does not invoke God anywhere at all. It simply describes how nature works. It's the first textbook of science. It does not invoke God. It does not involve miracle. It does not talk of irrationality. And I'll talk to you a little bit more about Vaishashika because it's the first textbook of science. It was the Rasnik holiday of its time. Rasnik holiday has been around for what, 60, 70 years. Vaishashika held sway over the secular knowledge of science for about 1,000 years before it was replaced by more precise textbooks in 16th century. Vaishashika is excellent at describing how nature works, but it is completely qualitative. It is not quantitative. So there is no rule, there are no Newton's laws of motions or anything. But if you want to generally broadly understand how nature works without having to invoke God or will of God and so on, Vaishashika gives you an excellent idea about how nature works. Nyaya investigates logic, what is correct, what is wrong, what is acceptable, and so on. Vaishashika is concerned with the nature and source of and limits of knowledge. What is known? Why does matter behave in the way? What are the properties of matter and so on? And I will look at Vaishashika again. Then there is Yoga and Sankhya, the first textbooks of medicine, somewhere between first millennium BC to early centuries of AD. Yoga is it tries to understand the nature of the worlds by union with the personal God. So even though we talk about yoga today as exercises and so on, at its foundation, it's a question of your relation with your personal God. It is not a worshipping, it's not a textbook of religious worship, no prayers or anything, but to get in touch with your inner self and to sort of go beyond your daily stresses and all that is what yoga originally begins by teaching. Sankhya, on the other hand, investigates what is being, what is becoming, what is existence, what is reality, and so on. And then you have this Mimamsa and Vedanta as the two great, last of the two great books. Mimamsa investigates what is dharma, and dharma is in the sense of duty of a human being. So laws, etc., come into being. What are the laws that should govern human beings? What are the attitudes that should govern human beings? What is right? What is wrong? What is socially acceptable, etc., comes up in Mimamsa. Sorry. And then you have Vedanta, which investigates the metaphysical reality. Is Brahman real? Is Brahman Dvaita or Advaita? And a whole bunch of other ideas come in at the beginning of Vedantic literature. So let me look at Vaishashika. Vaishashika is written during the great Renaissance period of Indian science. It is written after Hinduism been largely cleared of its ills by Buddhism and Jainism and other religious movements, which would clear a lot of ills that had come in due to Brahminical dominance of the religion. It also brings a degree of irreverence to the ancient definition. So there is no need to say that everything is by the will of God, etc. You can honestly investigate how nature works. It comes after, incidentally, the departure of Alexander, who has brought some ideas from the West about the working of nature. Unfortunately, Alexander did not think this axiomatic approach of Greeks was an important enough his idea to be brought. So when he brings his people, he brings literature and he brings stories, etc., but he does not bring any scientists with him to evaluate those claims. He brings astrology, incidentally, at that time. But it was after Ashoka, expansion of the kingdom. The Kalinga War is 265 BC, and after the pacifistic approach that Ashoka eventually takes, saying that killing is not a good idea, he adopts Buddhism and he has his edicts, etc., which are highly moralistic in their approach about how human beings or society should behave. And this is what Ashokan kingdom looked like at that time. You can see Maurya kingdom at 250 BC essentially covered everything from Krishna River in the south to the great mountain range of Himalaya in the east to the great jungles of Brahmagupta in the east to the north of Himalaya and to the left all the way until just beyond the Hindu Kush mountains. It was probably written towards the end of the Mauryan period, 322 BC to 185 BC, and as an academic fervor at its peak. And it held sway for 1,000 years. And the idea of Panch Mahabhut, the 5 great elements, actually comes from Vaishashika, and I will show you how that works. It held sway over an axiomatic approach for a long time. And it's a small book. It just has 373 verses in which it creates the entire structure of how nature works. And like I said, it is completely secular in approach. It doesn't bother about whether God exists or not, or whether there is a great Brahman or not. That is none of its business. It says straight away that there are 6 aspects to working of nature. Okay. it incidentally, at that time, it's general book of science. It is not physics or chemistry or biology. It is general book of science. So there is dravya, there is material. And in that material, you have solid, liquid, gas, sky, and energy, the Panch Mahabhut that make matter. But then there is also kala, which is time. And there is also dika, which is direction. So there are coordinates, there are time, and then they are graded for Panch Mahabhut. And then they worry about what life is. And they come up with this conclusion that anything that has a mind is living. But then rather anything that has an atma is living. Anything that is living has an atma, and when the atma goes out, it dies, the consciousness. And then they realize that, but there are higher levels of intelligence and lower level of intelligence. So they add an additional component of mana, which is what creates the intelligence. And the mana is a value is different in different life forms. So this atma and mana come from that time. Then the second important property is that all this dravya has a guna. It has color, taste, odor, touch, sweet, etc. Some 24 different properties. Then there are actions, karma or action. So there is a movement up, movement down. There's contraction, expansion, and displacement. And then there are Vaishashika, Vishesha, which are specialized properties of each given element. So water is translucent, bronze is brown, and so on. So that Visheshik, specific properties of specific piece of material that you're talking about. So solid will have a particular kind of solid will have Vishesh properties and also general properties and so on. And then there are inherited properties that come from their past existence, or in the past they may have been in some other form, where for example, bronze was mixed up with soil to be just general dirt. And some of the properties and some of the impurity of that dirt will be inherited by bronze when you sort of put it through fire and so on. And then there are samanya properties, the ordinary properties of existence, transient, and cause and effect. And for the first time, it defines cause and effect. And the causality becomes central to this very idea. If something has happened, there must be a cause to it. It is not a God-made miracle. If a stone was at a place A and it is found at place B, then obviously that displacement has happened because of some cause. The idea of causality as a basic rule of scientific working of nature comes for the first time in Vaishashika. So how do you read Vaishashika? First of all, classification. So physical manifestation of matter is this Panch Mahabhut. Life forces are in Atma and Mana. Emotions are in happiness, unhappiness, desire, aversion, and effort. Motion is, of course, in karma. Quantifiables, color, taste, odor, temperature, number, measures, etc. are there in quantifiables. And physical properties, fluidity, oiliness, elasticity, righteousness is more behavioral and so on, but demerit and sound. Some of the physical properties are here. And the chemistry, the basic idea of chemistry, measure, distinctiveness, conjunction, disjunction, otherness, similarity, and intellect. All that comes from chemistry. So essentially, the basic foundations are there. And how do you read that? I will come to in a minute. But I want to realize some important aspect. Causality is the first rule that comes up. So if there is an effect, there has to be a cause. And the cause must precede the effect. These are rules that are for the first time enunciated in Vaishashika. Substance is made of material and its properties. So there are dravya and gunas that make padartha together as a single unit. Dravya is neither created nor destroyed by karma. So the idea of non-destructibility, conservation of matter, etc. comes in. Guna is, on the other hand, are properties which can be destroyed by cause and effect. So if it's a circular ball, you can break it into square, deformation, and so on. Motion is a result of karma and is also opposed by karma. So if you're moving in one direction, you can oppose by another thing that is moving and stopping you from moving and so on. The changes in the guna is a result of karma. So heaviness comes because you've added matter or so on and so forth. Contraction comes because of cooling, expansion comes because of heating. So how do you read Vaishashika? So for example, if you're worried about fire, then fire essentially means that solid and liquid are given energy, and the conjunction of material happens, which releases gas and even more energy. And then it produces odor and it produces higher temperature. If you're worried about, say, motion, then you say that there is solid, which has specific properties of current, velocity, and momentum, and so on. and then you give a cause. You hit it with something or etc. And because of that cause, the displacement changes, and that happens in a particular direction over a particular set of time, and that is how you get motion in the universe. Why does the material move? Is because of this combination of touch and effect. And you can take almost any real thing that you experience, and you will see that you can pursue the line of arguments over here to understand how these things happen. The idea of Parmanu is there in Vaishashika, but it is not Parmanu in the sense that we understand it today. The adoption of that Anu and Parmanu into modern atom and nucleus is a 20th century touch-up. The way Vaishashika defines Anu and Parmanu are very different. So Anu, they assume that they begin with the assumption that all matter is continuous. It's interesting. And if they say that if I take a stone, I can therefore divide and I will get indefinite, because it is continuous, I'll keep on getting infinitely many pieces. And therefore I can make a whole mountain taking a piece of stone and cutting it continuously. And obviously that doesn't happen. So my basic assumption that matter is continuous is wrong. And therefore that paradox only suggests that eventually I'll reach a limit of how much I can collect, what is the smallest cuttability. And that is called the Parmanu, the ultimate limit on how much you can cut a piece of material. So there is this idea of eventual inductive logic. You make an assumption and look for contradictions, and all that is also there. Then they define Parmanu as something that is indivisible, eternal, and can neither be created nor destroyed. Each Parmanu possesses its own distinct specific possibilities. The logic, of course, is not fully correct. One can argue against this and so on, and there are arguments to and fro. Also, it is very far from the present-day definition of atoms and periodic table. They are nothing like that. Everything was Dravya. Anu is Parmanu with properties that make it a physical entity. So Parmanu is the indivisible, propertyless entity, which when it acquires properties called Anu. And Earth, Earth, Apa, Teja, and Vayu all have Anu. So solid, liquid, gases, etc. are all made of Anu. But space, on the other hand, doesn't have Anu. It is free of the atomic structure. And that is why you can have infinite amount of space. Translation of this Anu into modern atom is a 20th century interpretation. It is not there in original Vaishashika. Then we come to Siddhantic period, 580 to 1680. That is when you get formulation of astronomical problems in mathematics. In trigonometry gets invented. The formal algebra of zero is given. What happens when you divide by zero? Can you divide by zero or not? What happens when you multiply by zero, etc. Those rules are finalized at that time. And eventually the Kerala School of Mathematics would take India very far in understanding algebra, all the way down to limiting value theorems and differential algebra. And then we have the modern period. Taj Mahal is a very classical example of what modern period could do. Beautiful, unbelievably complex structure in its intricate designs and its stability. So even if if there is a major earthquake in that area and the towers, for example, fall, they will not touch the original structure. They have been slightly inclined to the outerward so that in case of an earthquake, it will fall out rather than fall in. That kind of intricate detail to design exists in Taj Mahal, apart from the aesthetics, of course. Then Tipu Sultan's rockets were a great invention. So Chinese had this idea of firecrackers and all that. So Tipu Sultan for the first time makes them proper rockets as weapons of war. And the Britishers are so hassled by the rocket that he makes that eventually when Tipu Sultan died, the armor in which he died was actually on display in British Museum, British Palace Museum until very recently, with all his blood stains and all that, because Tipu Sultan had given Britishers one hell of a time because of his invention of rockets. So not only it's a question of putting explosives and lighting it, the question of calculation of trajectories, the calculation of power, how much you can get a rocket to do, how big a rocket do you need to be to deliver a particular explosive, all those things Tipu Sultan works out. Then development of mining and metallurgy comes in. So for example, the zinc that is used in the bronze that is used in Indian bronze statues remains a unique composition of metallurgy. Similarly, zinc comes for the first time in India, and the purification of zinc, etc., is done through very sophisticated metallurgical works. and then there are so many achievements later on that one can hardly keep on listing them down. So the bottom line is that there was significant amount of scientific developments, each appropriate to its time and requirement. But there were a lot of things we are not good at. Okay, there are plenty of shortcomings. Amongst the shortcomings is that all matter behaves according to its nature, which means that description reaches a plateau. Once you say something is Prakriti Swabhava, there is no question of having Newton's laws of motion and so on. It remained a stagnant intellectual pursuit because the Brahmins who pursued it would not mix with artisans who were essentially low caste. Students of science avoided direct experimental studies, which would have required mixing with artisans and so on, which was a taboo. And that would essentially saturate Indian science. It would limit the nature of Indian science. Building of Harappan cities and Taj Mahal, of course, needed great artisans and great understanding of mechanics and structural mechanics and so on, but it never became a formal science. Social stratification ensured that subjects such as mechanics were not mathematically studied. There were several major fields we missed out. We missed out on gravity, we missed out on thermodynamics, we missed out on electromagnetism, and we missed out on structure of matters. None of these are systematically investigated. Similarly, optics and molecular biology, of course, are second generation science in the sense that you have to know properties of matter and then you make lenses and so on. And molecular biology requires microscopes and so on. And corresponding techniques were also not realized. So there is no electricity in ancient Indian sciences. Electricity comes to India with the Britishers. There is obviously no air or space travel because we did not know Bernoulli's principles and so on, and I'll come to that in a minute. And there is no uncertainty principle. There is no organ transplant. I'll handle each of these things individually. While there is a general idea of relation between disease and other life forms, in the absence of microscopes and in discovery of germs, etc., it remains vague. So, I mean, there's a patch of work of medication. So even though they had glass, they never made microscopes and did that. So yoga, Ayurveda has this classification of Prakriti and reactions and all that works to a large extent in terms of helping you with your local condition. So if you are one of those who are short-tempered, then acidity will be a problem for you and all that. And all those things work very well. So within the limitation that Ayurveda works, it works beautifully well. But if you ask them, why did COVID come about or what is Omicron, they would have no answers to that. So there is much to be proud of, but we don't need to exaggerate. Exaggeration today is fashionable, but it is irrational, and the exaggerated claims of our proud achievements, they simply give us a bad name. So some of the claims are that we knew quantum mechanics and uncertainty principles. Then we knew Vimana and aircrafts and planetary travels. We knew genetic engineering, including gender changes and so on. And we knew trans-animal exchange of atoms, and we knew atom bomb and so on. And we, of course, had internet because Mahabharata is recited to the king using internet. So, I mean, anything goes. And we will look at how each of these claims can be shown to be untrue. I get extremely irritated when this kind of nonsensical claims are made about India's past achievement. And the tragedy is that we don't need to do that. What is genuinely good is also very impressive. What they achieved for their time was phenomenal. A lot of work is trend setting and of highest quality. India had more than 30% of world GDP in 12th or 13th century. But we lost it. That's a different part of the story. So false claims, why make false claims when real ones are good enough? It is also such a dangerous trend that it gives everybody a bad name. China had somebody called Needham who went from Europe to China, and for several decades he and his institutions continued to study science technology in China, removed all the wild speculations, but did a very systematic scientific study. Even today, the volumes of Needham and his research institute are classics because they are reliable scientific studies. We need a Needham in India seriously. So let us look at some of the false claims. Okay. The argument that they put against these false claims are that how do you know that our Indian rishis did not know of quantum mechanics? You were not that. You were not there. And obviously I was not there. Even I am not at all. Then there are plenty of mythical stories of Ganesha and Shikandi. Shikandi had a confused gender. Ganesha, of course, has this transplant of animal head on a human body. And the claim is that you underestimate the genius of our rishis, etc. Since you are educated in Western style, you are slave of ideology, etc. The usual abusive sentences come. And if nothing else, the statement is that you are a lousy speaker, nobody can understand you, and therefore you must be wrong. If all else fails, abuse is the final arbiter. So let us look at this scientific growth. Accumulation of our understanding of working nature is incremental, and no science grows in isolation. Every idea about how nature works is tested by theoretical work and experiments. There are plenty of good ideas about how nature might have worked, but it turns out nature does not work like that. So for a long time, heat was thought of as a fluid and the material was thought of to be continuous. Now we know heat is just a motion, and we know that matter is not continuous. Experiments were the final arbiters of competing ideas. Science, therefore, is objective and testable and falsifiable. It is not opinion-based. A wrong idea, however attractive, are eliminated from science. So there is a broad sequence. Anatomically, modern humans come 1 million years ago. About 1 lakh years ago, we spread across the earth. Now, Indians, they come to India in about between 70 and 40,000 years ago. They learned farming about 10,000 years ago. The first cities come up about 5,000 years ago, and Sanskrit-speaking people enter India about 4,000 years ago. And evidence of Harappan is entirely archaeological, while the evidence of Vedic people is almost entirely textual. There is no evidence of war at Kurukshetra, and there is no idea what the Harappans spoke. And that has been one of the great conflicts of recreating India's ancient history. But the timelines are fairly well established. So let us look at quantum mechanics. How does quantum mechanics arise? Quantum mechanics arose because we had mastered electromagnetism and thermodynamics. And when you merge thermodynamics and electromagnetism, you end up with this crazy idea that electron going around an atom would have to give out radiation and would collapse into the nucleus and so on. And a whole bunch of things that were just not making sense. The stable orbits of atoms was a particular thing. And that resulted eventually in the formulation of quantum mechanics. Indians did not know of atoms and did not know of stable orbits, and we did not know that matter is discontinuous and there are 792 elements, and they have, there's no periodic table, and they have this electronic structure, etc. Similarly, so there is no way they would have come across quantum mechanics. Similarly, aeroplanes required to understanding of dynamics of air, wind, and Bernoulli's principle, and a whole bunch of experiments, which were not done. We needed an industrial revolution to make the internal combustion engine, which is a driving force for planes. So there is this broad, uneven description of a pyramid-like structure run by Mercury, which is supposed to be the early Vimana. People have actually made exact replica based on that descriptions and shown that they do not work. It is not an offhand claim that because there was no Bernoulli's principle, they didn't know aircraft. People have actually trusted, okay, whatever you're saying is correct aircraft, let us make it and see and show that it doesn't work. Similarly, interplanetary travel, first of all, requires a heliocentric model of the universe, that the sun is at the center and the planets are going around. We had only a geocentric view of the world. Then you needed powerful engines to make you move at 11 kilometers per second to leave the gravity of the earth. And then you needed a mathematical foundation. Remember, going to Mars is like hitting a 5 rupee coin some 40 kilometers away. That is a kind of precision you need. That is a kind of modeling you need. That is a kind of computational power you need. We had none of those things. So the claim that Indians could do interplanetary travel and go to Mars, and there are evidence of 2 kings having fought on Mars and their helmets are found, all those kinds of things are pure nonsense. There is no way we had the technological foundation required. It would require experimental facilities, test facilities, manufacturing facilities, an educational system, and so on. Some other example, genetic engineering. In order to understand that, you must understand the molecular level of life. You have to know DNA, you have to know what DNA looks like, you know how DNA works, and so on. You have to understand centrality of carbon to life. When we didn't even know carbon, there is no way we would have known that carbon is the backbone of life, because it is this beautiful 4-valence element which can combine with metallic as well as basic elements and give you these long structures and so on. You need to understand the double helical structure of the molecule of life. How is instructions coded in life? You had to have microscopy to understand and manipulate molecules. You had to be able to isolate these seals in clean and extremely clean environment at low temperatures to keep them inactive and then manipulate them. Similarly, atom bomb needed you to understand the uniqueness of atom. Why, for example, thorium is radioactive and iron is not. So you have to understand the uniqueness of atom. You have to have periodic table and then study these things further. You have to understand what is atomic fission. You had to, and then you have to compress it suddenly to make it critical so that it explodes. And there is no question of making it small enough to put it on bow and arrow. So when you say that Brahmastra was fired by Arjuna, etc., an atom bomb on Kurukshetra would have made it radioactive till even today. And it would have completely wiped off all the kingdoms. So when you talk about Brahmastra being nuclear weapon, etc., it is just nonsense. It is pure, unadulterated nonsense because it is physically impossible. Then most important, to achieve, and again, forget about individual pieces. There was a background that was needed. We needed powerful mathematical tools to do that. We needed electricity to run our basic labs, cleanliness, etc. We needed the concept of clean environment, appropriate structure. We needed education system. We needed technology system. We needed manpower. We needed computers in many of the advanced cases, etc. None of this was available, and can be conclusively shown that none of these are, none of them are existed, because there are, for example, there's a manual for making temples, but there is no manual for making a clean one. The argument that many of these arguments that use talk about our past often happily mix up sequence. So 16th century knowledge of limiting value theorem and differential equation is supposed to have been available to our rishis in 5,000 years ago, which is just not possible. So the idea of muddying water by mixing times, etc., mixing past sequences, etc., happily just makes no sense. It is clear, therefore, that many claims are not tenable. So every time somebody comes to you with a claim, ask them what does it require to achieve this, and do those background system exist or not, and you will find that it did not. None of these claims have been predictive. So there has never been saying that Indian science predicts that so and such a thing should happen. Just go and check it. It's always been post-dictive. I don't know whether that's a word or not, but it's always been post-factor. The bottom line is that there is much to be proud of in India's past. We don't need to manufacture facts. Our rishis were profound thinkers for their own period, but they never had the experimental backup that would have led them to test their ideas objectively and take them forward. So let us not make false claims of Indians having predated or preempted modern science. If it was true, then where is all that gone? Where is all that evidence for that gone? Thank you very much. So by making false claims, you are only making yourselves a laughingstock and can only harm our reputation as a civilization. There is no need for that inferiority complex. Thank you very much. If you have any questions, we can take them now.
Yes, sir. Thank you very much, sir, for the wonderful presentation. In fact, you will need a lot of time to explain on each and everything. So I'll go to I'm Dr. Srikumaran, Executive Committee member of Breakthrough Science Society, Kerala chapter. So we will take up some questions.
Sure. Will you read them?
Yes, sir, sure. In context of, it is from Preetham Bhattacharya. In context of humans starting to use wheels and horses for transport,
correct.
From what time did we first learn to build boats and rafts?
Boats and rafts are much earlier, much earlier. In the sense that we all believe that humans, when they migrated in 70,000 years ago from Africa, they actually came through two sides. So one was obviously the land route, which goes to Palestine and present-day Israel, and then eventually goes to Europe and Asia. But unfortunately, that ends up in the Caspian Sea. So it's the north of these mountain ranges that are there in the north of Iran. The second group actually takes a boat, jumps over the Red Sea, comes to southern Saudi Arabia, then takes another jump to come into present-day Iran and Persia and all that, and eventually travel to India. So the idea that wood floats on water is something humans observe very early. So boats would be much earlier than horse and land travel, comfortable land travel through chariots.
Okay, there is one question from Dr. A.I. Khan. He asks, the chronology of scientific development, as stated by you, is aggressively contested were religious scriptures
Yes.
and people's faith.
Yes.
How to make common people aware of scientific facts amidst aggressive propaganda using ICT contrary to scientific facts.
There's a saying in English which says that you can fool a few people for all the time and all the people for a short time.
Yeah.
But you cannot fool all the people all the time.
All the time, yeah.
At some stage, I'm hoping that movements like the People Science Movement and your movement for rational sciences eventually will start bearing fruit. For people where it matters, who sort of historians of science and so on, when they sit and think, they realize how much crap is there in the claims of ancient science. To others, it's a myth and mythologies. And given the aggressive nature of this thing, I really wonder whether it is worth spending energy trying to tell them, because they don't want to know it. Their national pride is involved in that story and all that. So sometimes I think that some people being foolish all the time, you just isolate them and leave them as it is. They should not become mainstream is important.
Okay. Okay.
So, for example, national education policy recommending that should be taught as proper science is something that we need to worry about. But otherwise, on the banks of Ganga, if somebody makes a stupid claim, you just let it pass.
Okay. One question from Mr. Vinayak Sanil.
Yeah.
Contemporary to Vedic ideas of karmic religion, the Charvaks birthed the ideas of Nastika.
Correct.
Why did Charvaks die out while Buddhism and Jainism survived?
No, so that's a question of local dynamics. Eventually, a religion will survive or not survive depending on how many followers you have, how aggressive they are, and what are the resources they can muster. Okay. Buddhism survives because Ashoka comes and likes the ideas. Okay. So it's a question of getting local support at the correct time. Many religions have died out. Okay. And in fact, I mean, I don't want to get into that discussion, but it's very difficult to define what is Hinduism. The Vedic idea is of havans and religious rituals. The Bhagavad Gita ideas are of that of duty and responsibilities and karma. Then you have a third revolution when Shankaracharya talks about Dvaita and Advaita. And then you have the fourth revolution when Gandhi talks about ahimsa being a part of religious structure and all that. So Hinduism itself, what is called broadly Hinduism, has changed its format so much. The gods, Indra is primary in Rigveda, is completely replaced by Vishnu in the later date, and Brahman is not worshipped, etc. Really, I mean, if you get down to the detail, every idea has changed, developed, and evolved according to what the time and place was. So it is stupid to say that ancient was right and modern is nonsense.
Okay. And one question from Mr. Raghavan Rangarajan.
Yes.
When you are referring to Nyaya, Vaishashika, Yoga, correct, and Samkhya
yes,
as the first books, do you mean first books globally or in India alone?
No, in the sense that they are not books in the sense of the books as we understand them. It need not have a preface and an index and the contents and this thing and back index or whatever it is and page numbers and printed. It had nothing of that sort. When I say a book, I mean a collection of verses which are to be learned together because they form a system of knowledge. So, I mean, Avesta, for example, can be called the first religious book because it talks about religious duties, religious nature, what is God, how do you worship God, etc. So, in that sense, Avesta is a book in the same sense as Vaishashika is a book. The earliest written books, as we would call them books in the sense of written material, which you can turn forward, backward and read it and understand it, is all palm leaf, which is much later. The earliest we have is this 3rd century AD, very famous book on which the zero has been identified for the first time. But that is about the earliest we have a formal book in that sense. But when I say Vaishashika as a book, I mean more in the sense of collection of verses which are to be learned together because they make sense of a particular knowledge system. Okay. Not in the sense of readability. Those are palm leaves that come much later. Bakshali manuscript is the oldest we know, 3rd century AD. But that is a very rare, there are not many written materials from that time.
Okay, sir. Another question from Dr. A.I. Khan. How far monopolization of knowledge by a few people and forcefully prevention and denial of access to knowledge to common people is responsible for the decline in science development?
Very heavily. very heavily. Because what happens is that people stagnate. Their ability to imagine, their ability to create, their ability to ask questions, everything declines with time. And if you have an endogamy, just as endogamy, children tend to be genetically not as fit as exogamous marriages. Exactly the same way, if your ideas are simply circulating amongst yourselves, you are bound to lead to stagnation, saturation, lack of creativity, and eventual disasters. So this idea that knowledge should be preserved only amongst the few and only they are authorized to discuss it and nobody else can participate eventually seriously harms us. So like I said, Al-Biruni actually notes that this Indian xenophobia and arrogance will eventually get them down, and it gets us down. So it's a very serious thing. Science has to be open. There will be criticism. There will be people who will say things that you don't like, or people who will say it in a manner which could have been said more politely, etc. There will be arguments, but that's all part of life, because that is the creative force and that is what will lead us further.
Okay, another question from Mr. Kaushik Subramanian.
Yeah.
The actual history and chronological evolution of Indian civilization is not recorded properly.
No,
not India alone, some African and also the Middle East. Then
correct.
how the evolution of scripture from ancient civilizations are properly interpreted?
So there are 2 or 3 things that you can do. One thing, of course, is the oral tradition in India is heavily encoded. So the linguistic structure that is in it is very heavily encoded. While the common language has evolved. So Rigvedic literature is not allowed to evolve, but then Sanskrit speakers, there is Pali, and there are other language, Kharosthi and other languages that are there, which are parallel to that time, which Buddhism actually quotes down and stuff like that. So evolution of language is one way of doing it. Archaeological evidence is another way of doing it. And the description of the society, if you go through carefully, you will be able to date it. For example, if you look at, there's a beautiful piece of work by somebody called Kanat Sinha, an Oxford University publication, beautiful piece of work, where he shows that the early Mahabharata is a very classical clan society. It is not an urban civilization. And only towards the end does it eventually go into urbanization, where the king is defined, his responsibilities are defined, how he should behave, etc. is defined. But the early part is essentially a clan society. So you can look at social evolution, you can see linguistic evolution, you can see technological evolution, and you have archaeological evidence. That combination gives you some kind of dating. And now, of course, if you can find artifacts, then you can do carbon dating and stuff.
Okay. And one question from Mr. Rajashekar. Is Mahabharata history or mythology? If history, are there any verifiable proofs available?
Okay, so Mahabharata calls itself Itihasa. Ramayana calls itself Kavya, but Mahabharata calls itself Itihasa. In that sense, it claims to record history. But there are plenty of issues. So, for example, if you go to Kurukshetra, no matter how much you dig up, you don't find millions of arrows. Now, if the Mahabharata war had been on the scale which is described, then you should see millions of people who were simply buried or cremated there in large numbers. That their weapons, the bows and arrows, especially the arrow body may be wooden, but arrowheads were essentially must have been metal. So those metals should be remaining there. You should see all those things which you don't. Okay. So Mahabharata, though itself calls itself history, there is certainly an element of exaggeration in that. There is also an element of later mixing. So Mahabharata originally starts as recitation from bards who are telling the stories of your great ancestors who had done this and who had done that. And then over a period of time, things start getting added to it and so on. So even though it probably has elements of Itihas in the sense that there was some form of war between 2 brother groups about ownership of the kingship of Mahabharata and all that, etc. But there are so many moral dilemmas, so many behavioral issues, etc., that they all get added and eventually people add their own creations and so on. So if you look at the earliest bards, say in 1000 BC, who were talking of the stories of Mahabharata, they would not recognize today's rendition of Mahabharata. But if you look at 3rd or 2nd century BC bards, they would probably recognize our current rendition of Mahabharata as correct, as similar to what they had. So these things evolve. Yes, there is evolve. The problem with ancient India, like I said, is all the Harappan civilization evidence is entirely archaeological. but all the Vedic civilization literature is literary. There is no archaeological evidence mapping, allowing us to map those two periods. You have stray evidences. So there is a mention of a kingdom called Maluha in Persia, 6th century BC, where people from Maluha, which was east of Hindu Kush mountain, came and paid their respect to one of the great kings of Persia. Then there is a discussion of religious practices followed by people who live to the east of Sindhu, and any religious practices to the east of Hindu is called Hinduism. S becomes H in Persia, so it becomes Hinduism and so on. So there are stray evidences in West Asia, there are stray evidences in other places, but there is no formal, the concept of history in India is very different from concept of history in the West. So Mahabharata is in some sense historical, but a lot of philosophical ideas have been added, and one needs to critically look at it to see which came later and which came earlier. But it can be done, and it has been done. So if you look at, for example, Sinha has a very nice book called From Dasharajanya to Kurukshetra. In that book, he analyzes this, the historicity of Mahabharata, and he tells you that a lot of elements are historically sensible and possible. Minor details here or there may be added later, but a broad history of that period can be created even from the Mahabharata text itself. In that sense, Mahabharata text is historical. On the other hand, Ramayana has so many gaps in content. So the way, for example, Ravan's kingdom is described is so casual and careless, where the knowledge of geography is also poor and so on. So there it's very difficult to recreate back as history, and therefore it is classified as Kavya even from ancient times. Well, Mahabharata is called Itihasa because to a large extent you can make out what is happening historically. Ideas evolve, civilization evolves, culture evolves. There are moral arguments, moral dilemmas that are typical of that kind of arguments, living systems, and how those arguments eventually lead to a better society and so on. So in that sense, Mahabharata is Itihasa, but Ramayana is Kavya.
Okay, sir.
Yes.
Let me take a few questions from the YouTube.
Okay.
There's one from Mr. Matthew James. Do you
Yes.
think this unhealthy obsession with the past is somehow impeding our abilities of
Yes.
science progress?
It definitely is impeding because free thinking is being discouraged, free history, evaluation of history is being discouraged, and also the precious resources are being diverted to unnecessary things. And in that sense, yes, it is creating an intellectually stifling environment, it is creating a financially strained environment, and it is not allowing people to think, and that cannot be good. When that happened in 15th and 16th century, India eventually went down the drain and into its dark ages. History tells you that if this period continues, it will be very unkind to history, the future of India. Yes. Any other question?
Dr. Srikumaran, you have to unmute.
One question from Siddhi. As per Ashoka's inscriptions,
Can I stop my share?
Ashoka's
yes.
inscriptions.
Yeah. Yes, sorry.
Which among the following place was declared tax-free and proclaimed as 1/8 part as taxable?
Oh, I don't know Ashokan history well enough to be able to comment on that. I'm sorry for that.
Yeah, I'll come back to Zoom itself. There is a question from Chinmay.
Yes.
There is no periodic table and classification of elements, and hence no way for making compounds and mixtures, and hence medicines could not be have been there. Hence, there was no medicine in ancient India. Is that true?
No, that is not true. In the sense that plant-based derivatives can always be mixed to give you, even why just humans, even chimpanzees are known to have medicines. They know that when they've eaten something that has irritated their stomach, they can go and chew leaves of a particular plant to give them relief. So in that sense, medicine exists. And definitely the plant-based medicines made sense. And you knew you could mix them, etc. What you did not understand was the basis of it. Why or how does that particular combination work and can I make it artificial, etc., doesn't exist. But for example, salt, a lot of things in Ayurvedic knowledge, which makes full sense. And unlike homeopathy or something, Ayurveda is an accepted scientific method of understanding plant-based chemicals that can help us alleviate our illnesses and diseases. There's no issue with that. So there were definitely medicines there. And in fact, to the extent that British doctor actually records in 18th century about the plastic surgery being done by soldiers. So he notes with great worry that, look, these Indian soldiers, we cut off their necks, noses and hands and noses and stuff like that. And next day they come back looking perfectly fit. Clearly Indians are able to reproduce their noses and ears, etc. overnight. And they have a technology which we don't know. And we know from the other side that this is plastic surgery. So all the way up to plastic surgery happens, surgeries happen. And that is all very valid science, but it is not allopathic. It is Ayurvedic, but it is not unscientific by any stretch of imagination.
Okay. Let me combine two questions. One from Mr. Raghureddy Pandian and another from Mr. Vinayak Sanil. When the architecture of Taj Mahal is praised, many counterclaims of better architecture of temples, example, Brigadishwara temple. What in your opinion?
My first question is, why fight? I mean,
Sorry?
yes, why fight? Taj Mahal is an excellent, beautiful architectural design on its own. So is Meenakshi Mandir. So are so many other temples. So lots of people created excellent architecture in India, and it was driven by desire for excellence. There is no doubt that there are some temples that are architecturally simply magnificent. If you go at Kailasha temple in Ellora, for example, it's a technological marvel. It is certainly a technological marvel. And so is Taj Mahal. And the medium used is different, the technology used is different, the idea used is different, etc., etc. You can't compare apples and oranges. I can have a nice apple and a nice orange, and except that I have nice fruits. Similarly, India has excellent architectural monuments in India, starting from 15th, 16th century. Temples start about 13th century, etc., etc. So it is not a conflict between a temple architecture and Taj Mahal. Each of them is beautiful in its own way, and we must accept and appreciate the elegance and beauty of each of these. There is nothing wrong with that.
Yes. One question from Mr. Vinayak Sanil. What about the claims that ancient Indians already knew that the earth was round and they already knew heliocentric model even before Copernicus and Galileo?
No, that's not so. Brahmagupta talks about that. Look, these stars going around in the night sky seems such a fantastic thing that maybe just as you going on a boat see the trees on the coast moving in the opposite direction, maybe it is the earth that is spinning and the stars are constant. He makes that speculation for the first time, but he's promptly mocked and promptly made fun of by Varamir and others, saying that what a silly thing to say, because if that was a situation when you throw a ball up in the sky, it would land behind you, it does not land on you, the birds would not be able to find their way back, etc. The usual arguments against the spinning of earth. So that discussion is there, but heliocentricity is not there. Heliocentric, so what happens is that this epicyclic calculations are made for the planetary motion. So there's a big ellipse in which the planet moves around the earth, and then there is a small ellipse sitting on that big ellipse to give you this retrograde motion and all that. Those kind of calculations are there in Europe. We also adopted. But unlike Europeans who are obsessed with the geometry and issues related to that, Indians consider it simply as a calculation convention. So they have lookup tables for sine functions and all that, and they do that. But the idea of heliocentricity is not there. It is still geocentric. But there is an argument that maybe the earth is spinning, but it is not taken seriously and it is mocked very early. So, I mean, it's a good place where healthy discussions were happening. 5th century India was rich with all kinds of arguments and discussions, some right, some wrong. But that is how it should be all the time.
Okay. One question from Ms. Chinmay. What is your view on Garbha Upanishad and your views on the works of Kannada? I didn't understand that.
Yeah, Kannada is the one, I think, is the author of Vaishashika, if I'm not mistaken. And Garbha Upanishad, I'm afraid I have not read. So I'm sorry to disappoint you.
Okay.
Kannada, I think, is the author of So Bhugol, etc. are later words. So there's somebody in the chat I just can see popping up saying that Bhugol means that we knew the earth was round and all that. That is not really the correct interpretation. Bhugol is a much later word. Bhugol is not in original Sanskrit literature.
Okay. How much communication was there between different civilizations like India, China, India, Arabia? It is asking
it has varied with time. So, for example, we know Harappans were trading with Persians. We know of Indian boats having gone to Persia. Indian seals can be found. Indian jewelry can be found. Similarly, during the Greek peak period, we can see Greek coins, etc. Alexander came here. Persian kings, we went to the king. Darius is the king. The great Darius is the king of Persia, where Indians, there's a panel in Persepolis where there is clearly Indians who have gone there to pay them homage and stuff like that. Then there are dark ages, especially when Arabia goes dark, the communication between India and Europe breaks. And whenever the Arabians are there, because you need to travel through. And Silk Route is much further to the right, further to the north, so we don't use it. We travel along the sea. So intermittently, that communication continues to be there. There are people who believe that because Persia went down because of famine or whatever it is, the entire Harappan economy is based on exports, and that is why it crashed. So there are people who believe even that. So Indian connection with the West has been all through, in varying degrees of intensity, depending on how the channels of communication were there.
Okay. One Sachin Jayachandra Shenoy wants to know the scientific basis of Ayurveda, Siddha, and Unani practice.
I'm not an authority on these things at all, by any stretch of imagination.
Yes.
Ayurveda is not something but the classification of personalities into reactivity to substances, etc., has been repeatedly shown to be scientifically valid. Double-blind tests, etc., on Ayurvedic medications, etc., show that it works.
Yes.
Unlike homeopathy, for example, which definitely doesn't work. And homeopathy, by the way, is not an Indian system; it's a French system. But homeopathy doesn't work. So in that sense, Ayurveda is, in every sense of the word, a scientific system. And until the idea of isolating molecules which have a specific effect to give you drugs that comes up in 16th, 17th, 18th century in Europe, Ayurveda was the best medical system anywhere in the world.
Question from Anne Joffin. How is the Nagara style of temple architecture different from the Dravidian style of temple architecture?
Okay. So the question is of philosophy. A temple, incidentally, temples are not there in Rigveda, temples are not there in Bhagavad Gita, temples are not there in Vedantic philosophy, etc. They are a reaction to Buddhism. When when Buddha passes away, they make these stupas, and the Hindus realize that stupas or architectural design structures are good to keep your flock together, and that is how temples come to India. That is one issue. In that, there are philosophical differences between North and South. So the temple is supposed to be the cosmos that comes from heaven to the earth. And the place where you worship, the Garbhagriha, is where this symbolic entry of gods on earth comes in. So everybody has a Garbhagriha, the central place where you happen to worship. The problem, the difference is that in the Nagara style, the Garbhagriha is the central piece of the temple. It is the tallest structure. It is a flag on top. It is most beautifully carved, etc. Then in Nagara style, where the kingships were important, there is a secondary hall in front where the artisans used to perform, the dancers used to perform in respect to the king, and the king would come and listen. And then there would typically be a third room where the people from the kingdom can come and witness the dance or art or whatever it is. So it has these three halls. The primary hall is the Garbhagriha, where the god sits and where the worships happen. And then there are two more halls for the audiences for various artwork. Dravida style of temples are fundamentally different. The Garbhagriha is the least attractive structure amongst all. The most important structure amongst Dravida temples are the four entrances. And they are large, they are tall, and they are beautifully carved. And the internal structure of a Dravida temple is differently laid out. But there are some foundation similarity because they are essentially a representation of the cosmos on earth. So the Garbhagriha ideas are similar, but what is important, what is emphasized is different. And I personally believe, I haven't tested, I checked it with other people, but I personally believe that the reason is that South India is full of megalithic structures which used to keep track of the sun and the moon and so on. And these megalithic structures were large stone structures. And you needed to sit in the center of that large stone structure to be able to figure out exactly what it is happening. If you want, there's a structure at Baise, and we have published a paper in Current Science on that, where you had to sit at a center to see how the shadows play out in order to be able to make directions, etc. So these ideas of large structures on all sides, and then in the central region from where you do all the studies, where a great learned man would be able to tell you whether monsoon is coming or summer is coming, etc., is an idea that remains in the background of worship. And when temples come in, they adopt these thoughts. Is my personal belief. I have no scientific evidence to show that. But the emphasis in Dravida temples is on the Dwarpalas, the great Dwaras and great Dwarpalas. Typically, they tend to be north, south, east, west, but that is not guaranteed. On the other hand, Nagara style have this Garbhagriha, which is central to the temple.
Okay. There's a question from Kevin Chaco Mundakar. From which place did Aryans originate, Europe or Central Asia?
Okay, so the common belief is that the human group that migrated from Africa along Palestine or Israel, if you want, and settled in Central Asia, which is to the east of Turkey, eastern region to Turkey and so on. From there, eventually, they would diverge into two groups. So one group goes to Europe and the other group comes to India. Now, there are two ways of coming to India. So there is this mountain ranges on the north of Iran. I forget that name of the mountain range. I think it is Ural, but I'm not very sure. So that mountain ranges are not easy to penetrate. So people who went from Palestine straight north came to the bottom of the Caspian Sea, and then they traveled to the north of these mountain ranges, and eventually at Khyber Pass, they enter India. The second one is that you come along the coast. So you come along Euphrates, Tigris, eventually enter into Iran. Iran is largely a desert, but there are times in history when monsoons have opened it for a few decades and stuff like that. So they come through that. Then they see Bolan Pass, which allows them to cross the Hindu Kush and come into India. So the population of India has multiple layers. There are 4 different layers of populations in India: the Dravidians, the Indo-Europeans, the Austroasians, and Tibeto-Burmans. So we believe that Tibeto-Burmans are the people who came along later on Khyber Pass and kept along the mountain ranges of Himalayas and went into Southeast Asia side. There's another group that comes along the coast that probably becomes Dravidian, but largely goes into Australia and Southeast Asia, that is Austroasian. Then there are these Indo-Europeans who are Indo-Europeans not in the sense of having come from Europe, but because there's population groups went to Europe and to India, and that come also from Khyber Pass and that other. And then there is the Indo-Iranian group that comes from Persia through Bolan Pass, and that makes it Indian. So when you say Indians being called Indo-European actually is an ideological fix on the Indian population. We are more likely to be Indo-Persian rather than Indo-Europeans. Genetically also, these are similar groups and stuff like that. So Indians are a mix of the larger population group in India, especially north of Vindhyas, is a mix of Indo-Persian and Indo-Europeans. And then in the southern part, you have Dravidian group, which is an independent group of its own right, plus Austroasian. So if you look at Andaman and Nicobar Island people, they are essentially Austroasians, remnants of people who eventually migrate to Southeast Asia and Australia. So India has been considered a crucible of ideas and people from the beginning, and that is not wrong. We have the largest genetic diversity anywhere in the world.
Okay, thank you very much, sir. Let me take up this opportunity to thank Dr. Mayank Vahia, who is a professor in the Department of Astronomy and Astrophysics at the Tata Institute of Fundamental Research, Mumbai, for his valuable time spending with us. We really enjoyed the talk. And on behalf of the Breakthrough Science Society Calicut, Kerala chapter, I thank Professor Mayank Vahia. Along with that, I thank all the participants who interacted wonderfully in this program. Thank you very much. With that, let us conclude this program. Thank you very much.
Thank you. Thank you.